Hello everyone, my name is Jim Rambo, Technical Trainer with the GSA, and today we're going to talk about distributed crawling and serving. The purpose for distributed crawl and serve is to be able to create larger corpuses of documents, larger indexes, beyond the 30 million documents that one GSA can handle. So what we're going to do is talk about how to put these, assemble these collections of GSAs together so that they can create a larger composite index, and then we'll show you how to configure and test that. There are two solutions for creating larger corpuses of documents beyond 30 million documents. One of the ways is to do it through unification, and in those cases the GSAs maintain their own separate indexes, but it doesn't provide as good of relevancy because we have to merge or thread the results together at serve time, and the relevancy calculations come from each of the GSAs. So each GSA is not totally aware of the other one's index. Better approach is to set up distributed crawl and serve, and in this case we'll configure one search appliance to serve as the master, and then the other GSAs will be set up on what we call different shards. These shards are fragments of the index. The master will divide up the crawl and index load and distribute the URLs to the various GSAs, and it will create one master index. Now the advantages here is scalability, can go beyond the 30 million documents. All GSAs act as one to handle more documents, so we get one index. There's no threading at serve time for relevancy. The relevancy is good across all GSAs as if any of the documents had come from one GSA. All configuration is done on the master node, which is shard 0, and distributed to the other GSAs. The only exception to this is Kerberos and SSL certificates, which are host specific, so you'll have to set those up on the other shards as well. You can search on any node, however each GSA contains a portion of the index, so if you lose one of these search appliances, network connectivity issue, or a GSA failure, then those documents in that portion of the index will not be served. The features are that we support mirroring. All systems must be on the same software version. All systems must be on the same appliance model, meaning a 7007 or a 9009, so you can't mix and match. All appliances must be in the same data center. This is a highly recommended configuration because the bandwidth traffic between these GSAs can be very high. Now the limitations are that we do not support unification at this time with distributed crawl and serve. Each document is stored on a single node, so if the node fails, all the documents on that node will be missing from the results. And if using a load balancer, you will get much better performance if you make the session sticky. So if a user initially opens up a session on shard 0, they will return to that GSA on subsequent search requests. That way you don't have to log in twice. This is how distributed crawling and serving works in your network architecture. The GSAs will use a secret token and a private IP network to set up and establish a VPN tunnel. We're going to need to use ports 500 for UDP and 51 for IP traffic, and there will be private IP addresses assigned to each GSA. Each GSA will need to see only the public IP address of each GSA. The way to set this up, on the master, meaning shard 0, we will pause the crawl, enter the number of shards and the total number of nodes, and then click Enable Distributed Crawling. There we'll add and define each shard, and then we'll click Transmit Configuration, and then Apply Settings. And then we'll restart the crawl on the master. Under shard configuration, we will define these characteristics, such as whether the node is a primary or a replica, meaning if you set up 3 GSAs for 3 different shards, each of them might have their own replicas. So you might have to set up a total of 6 nodes. So you'll specify whether this node is a primary or a replica. You'll specify the host ID and its IP address, and then the credentials and its private IP tunnel information. It's also important that you send all the feeds to the shard 0. So if you're using feeds, connectors, they all have to point to shard 0. Let's see how to set this up. I'm going to set up two nodes. Shard 0, which will be the master, will be GSA 14. Here's its administration console configuration. Notice that it's crawling content on many directories. If I search for results for on this GSA for health or painters, I'll get search results. On GSA 17, I will only be crawling a few directories with health documents, and if I run a search on this directory, on this GSA, I'll see results for health, but not for painters. On GSA 14, I will go to Crawl Diagnostics and pause the crawl. And then I'll go to configure the nodes. So I'll go to GSA to the N. I'll specify 2 shards and 2 nodes. If I had replicas for these GSAs, I would specify 4 total nodes. The 2 shards appear, and I'll edit the first one. So this is the configuration for GSA 14. I'll specify it as a primary, not a replica, because I'm not using mirroring. I'll provide its appliance ID and its IP address, and then the user administrator user ID and password for this GSA, and I'll give it a private IP address 10.0014. And a secret token. I'll save the configuration settings. I get status of success. This only means the configuration was set up properly. The configuration is set up. I'll go to shard 1 and edit it, and I'll add a node for GSA 17. It's also a primary. I'll provide its appliance ID, its public IP address, student ID and password, and I'll give it a private IP address of 10.0.0.17 and its own secret token. Save the configuration. Now the configuration has been set up. I haven't applied the configuration yet, so let's apply the configuration settings. When I do this, the private IP tunnel is going to be set up between the 2 GSAs. The load is going to be distributed out to shard 0 and shard 1, and the crawling and indexing will begin when I click resume crawling. Let's go to network diagnostics and check to see the status. Notice that the ping was successful. You should see that right away as green. If it shows up as red, it means you didn't provide the right public IP address for the shard 1. Now I'm going to see status as red. It's going to look like it's failed right now, but it's not really that status. It can take up to 2 to 3 minutes to set up the private IP tunnel. Just keep checking back on status. All right, now the VPN tunnel has been set up. I can go to Crawl Diagnostics and resume the crawl. Notice that the timestamp has been included for the last configuration synchronization. Now go back to Crawl Diagnostics and start the crawl. This shard 0 will divvy up the URLs, distribute them across its shards, and those shards will start to crawl. On GSA 17, we now get a large warning that this is a non-master node, so don't make any configuration changes here. But you can go to crawl and index and notice that all the URL patterns from shard 0 have been synchronized. That's it for configuration. Now, there are some other points to consider. When you're recovering from a node that fails, you have different cases. You may have a master node, you may have a non-master node, and so there's different steps and procedures for them. Go to the documentation to see the details. If you're dealing with a mirrored configuration, you have different steps for whether it's a primary or whether it's a replica node. And there are, in this case, there's 4 different situations. You could have a master primary or a master replica, or a non-master primary and a non-master replica. Upon node failure, this is just general guidelines. You remove the failed node from the configuration, replace it with the newer replica node, export the distributed configuration file and then import it into the new config file on the affected nodes. But there are specific steps, so read the documentation. It's easier to add or delete nodes by adding them to the configuration and then enabling or disabling them using GSA to the end add nodes. Now, what this means is go ahead and if you're anticipating that you're going to put together, say, 4 GSAs, but you only have 2 to put together, why not go ahead and set up the configuration for all 4, and then what you can do is apply your settings later. One last note is that if you're putting together large clusters of GSAs, we've scaled up to 1 billion documents, but you might want to contact customer support for instructions on dealing with large numbers of GSAs. So we've described the features and benefits of distributed crawl and serve. You may want to consider unification as an alternative. See the training for that. And we've also showed you how to configure and set this up and test it. For further information, consult our documentation.